Hey guys, my name is Nicholas and I will be presenting on the co-occurrence of refactoring of test and source code. This work was done in collaboration with Dr. Rabia Abdelkarim of Carleton University. So refactoring is known as an important technique to improve the quality of our code bases. However, previous research has also shown that the refactoring of test code is an important practice to avoid test code smells which hinder the performance of your test code. In our research, we see that source code refactoring commits actually occur a lot more often than test code only refactoring commits by a large margin. However, co-occurring refactoring commits actually also occur a lot more often than test code refactoring commits. And co-occurring refactoring commits are commits that contain both source code refactoring changes and test code refactoring changes. And that is going to be the main focus of our study. So what is the main thesis of our paper? So what refactorings are performed on the test code during co-occurrence, and when should they co-occur with source code? So to that aim, we analyzed 77 projects from the SmartShark dataset, and we applied a tool called Refactoring Miner to extract the refactoring commits from those 77 projects, which allowed us to get the files that were touched by those refactorings in each commit and apply Java parser on each of those files to determine whether they touch source code or test code. And as a result, we were able to classify them into three types: either test code only, source code only, or co-occurring refactoring commits. And so what are our results? So we see that these are the 5 main types of refactoring operations that you would apply to test code during co-occurrence. And the most prevalent by far is the change variable type. So what does this figure imply? It implies that when you refactor source code, your most likely operations that you're going to need to do are the change variable type, or move class, or rename method, or the other two that you see in this figure. And so what can we predict? Can we predict whether developers should refactor test code while they are refactoring their source code? Whether they should be co-occurring when they're refactoring their source code. And so we take source code refactoring commits and co-occurring refactoring commits from our data set that we got from the previous step, and we extract features. These features include features from the source refactoring commits to be able to predict whether they should also be co-occurring at that point. And some of these features include developer refactoring experience, or the refactoring size of each of these refactorings applied in the commit. And then we apply various statistical models. We settle with the random forest model since it gave us the best results. And doing a little bit of optimizations, our results went to the moon. So coming back to the ground now, these are the actual results that we achieved in this step. We use 4 metrics to be able to evaluate our model: AUC, F1 score, recall, and precision. At the 50% mark, this would be like our model performing completely at random. However, in the majority of cases, we see that we perform a lot better than that, and we see that we achieve actually a median AUC of 74 across all the projects that we used at this step. So this concludes our project, our presentation. If you have any more questions, feel free to reach out to either me or Dr. Rabia Abdelkarim. We would be super happy to answer you. So thank you guys, and have a good day.